talk to other WarsawJSians, and do other fun things. Right. There's a very long slide. But yeah, WarsawJS is a community, as I already mentioned. And most important thing is everyone knows what Berlin Code of Conduct is, right? No, who does not know what it is? Raise your hand. Just one person. All right. So specifically for you, I'm going to note it. Don't be ashamed. It's all right. No one you don't have to know this. But Berlin Code of Conduct is a very long document that basically, if you sum it all up in one sentence, it's just don't be a jerk. Be a nice person. Be a nice person to other people. We accept everyone. We love everyone. We welcome everyone in our community because WarsawJS is for everyone. Right. That is me. This is my name. I'm going to be MC for today. But most importantly, the event would never happen if we didn't have our amazing team, which is Piotr and Sasha. So yes, start clapping. Thank you so much. Right, and even more importantly than most importantly is that we have a team of amazing volunteers. So give them a clap, a little clap as well. I think give someone a clap in British-ish English is not a very nice thing to say, so I kind of feel bad right now. But well, if you know, you know. I'm so sorry. It's give him a hand. Yeah, that's what I wanted to say. Right, but most importantly, again, we need you to be here if you want to. And if you want to become a volunteer, if you want to help us run this amazing event, meet the most amazing people, and sort of get a free pass of getting behind the scenes of all the action, you can scan the QR code and email us or send us a message on Slack, to which we will respond. And yeah, you get a chance to join this amazing community and sort of work together to make this a lovely event. Right, I've seen some people scanning. Yes, this is actually, the most important thing is this slide. I keep forgetting, but yes. No events without the talks, which was, it could be fun, to be honest, to just assemble and network for 2-3 hours. But well, there's not going to be an event without the talks. And to be completely honest, we are a little bit short on talks. So if you always wanted, I think I've seen some people today asking if you can speak. Yes, you can speak. You can speak. I've seen you ask. So did you scan the QR code? Perfect. Thank you so much. So please be our next speaker. And if we're going to have no speakers, I'm going to be the one doing all the talks, which is going to be very sad. And I'm going to be exhausted. Right. Anyone else wanted to scan it? No? Perfect. One more person. Did it work? Lovely. All right. So, and most importantly, once again, everything is important. We have Ramp Network and XFang sponsoring event. Thank you so much. It means a lot. And of course, we are in this wonderful space of Ramp Network, which has an amazing view. We got a bit of a, that's a bit of a sad of a weather today, but doesn't kill the view still. Right, and I would love to invite someone, I think it's Artur. Yes, there you are. Please welcome to the stage and give us a couple of words about the Ramp network and everything else. Yep.
Yeah, thank you. Hello, as you can see by my shoes, I work here. We are enjoying this beautiful view and seeing if the level of water in the river is already back up or not. Not yet. So I've been given the honor to welcome you here in the absence of our CEO. As the eldest engineer on board. Yeah, so what is Ramp? We are a Web3 company bridging the traditional finance and the crypto finance. So we make an embeddable widget where you can onboard or offboard of the crypto world, top up your wallets and so on. And we are working on new exciting features. I'm not yet sure which ones can I disclose to you, but there will be more. We are working in TypeScript since the very beginning, both on front-end and back-end. We use Nest.js and many other funny technologies. You can ask me later for details. We've helped organizing Warsaw TypeScript and Warsaw JavaScript a couple times. So we are very fond of your companionship. If you want to see how to join us, you can scan this QR code this time. Although I don't think we are looking for engineers right now, you can see when we are. Or you can send it to your friends for other roles. Yeah. And also in this beautiful office, you can sometimes meet if Warsaw, the blockchain foundation for Ethereum, the Warsaw division. They just opened a co-working space named Collective Free in half of our office. So you'll be able to meet them here and also sit down and work with them if you want. Yeah, and now I'll give the mic back for the presentations.
Thank you. Thank you so much. I am a big barefoot shoes enthusiast, and I can really appreciate just rocking the bare socks in the office. I wish I could do that. I don't go to the office because I have no job. Anyway, of course, we also have, aside from our beautiful host and sponsor, we have KMag and JetBrains sponsoring us. Yes, thank you. And as usual, as per usual, we have so many JetBrains licenses to give away that we don't want them. So after every single talk, you're gonna have sort of a small slot to ask questions. If you ask, so we were gonna ask speakers to select the one singular best question, and the best question. The person who asked the best question receives 1 year JetBrains license. Just like that, right? And yeah, that's the story. So coming up on our amazing speakers, we have, I'm sorry, I am not a native Polish speaker. I'll try my best. So we have Karol Waszczuk talking about hoisting. And this is honestly one of the longest talk titles that I have ever had on the meetup. So it's hosting. Basically, there's a lot of stuff about PNPM and Node modules. I'm gonna explain a little bit more later as the talks come up. We have Jakub Grzywaczewski. Is this the right? That's the right. All right. About Blazor, I've always been intrigued about all the things about Blazor and how can you run C# in the browser? It's crazy. And we have Patryk Wojnarowski. This one, the last name I don't know, which is no Vercel, no problem. I agree with that. I don't like Vercel. They sell too many triangles. And of course, with the lightning talks, we have Rafał Pocztarski. Pocztarski, that's the right. Yeah. About switching to Go and TypeScript. And Hubert Sosiński. Should we cancel cloud? Yes, we should. Because, yeah, roll your own infra, I assume, right? So with that in mind, I invite our first speaker to the stage. And yep, thank you. Karol, are you coming? Where is our first? Yep, come on. There you go. Wait, that's not the right one. So that should do the trick. Okay, you can take this one. Here we go. Once again, please give a small hand. Thank you.
Wait. I just set up so I know how many time has passed. Just give me a second. Okay, we go. I'll put longer, but we'll see. No problem. Okay, hello everyone. I'm Karol. And today I'll be covering the topic of the node modules and actually what darkness lies within it, what kind of the monsters are there. As you may trust me, there are some. But first, let me introduce myself. I'm Karol. I'm working here at Trump Network as part of the platform team, where we are making sure together with my colleagues that our platform and our system is working smoothly 24/7. On a private line, I'm the huge fan and enthusiast of the Lovecraft's writing, the way how he storytell the horror-like stories, and at the same time, I'm the passionate tabletop game master, telling and leading the stories for my players in the worlds like Call of Cthulhu, Warhammer, or D&D. And those last 2 points means that I have quite of an experience with monsters themselves. So perhaps that's why a couple of months ago, my team told me to deal with monsters in our own node modules. Perhaps they misunderstood me when I was like bragging about killing the demon in my last D&D session, but whatever. Speaking of node modules, we all heard about them, we all see them, use them every day. And I don't know about you, but I was always haunted and really scared of seeing them in real world, seeing how big of them, how big they are, and that even the smallest application can bucket this whole monstrosity sized of the node modules. So I was scared, but then I just got curious because I could not believe that it's possible in JS that even such simple application ends up with like this 12 gigabytes of dependencies. So I ventured into those darkest depths of the node modules to find out what waits for me there. And I've been really shocked because I found out multiple monsters hiding in each of the corners. The monsters that really like to consume your minds, your sanity, and so on. I survived the face-to-face encounters with those monsters, and right now I can share my findings with you. So you can become one of those sexy bastards, the Ghostbusters of your own. Or if you prefer to use some lightning powers, you can become also the paladin and eradicate those monsters with lightning smites after the presentation. I permit this. But let's first travel to the past when it all first started, to the year 2010, the dawn of Node.js, when the Node.js was first created, as well as the NPM itself. It was the era of so-called nested node modules. The name is basically like this because back then, when you were using the NPM, you would end up with structure which was basically nested. Actually, if you would like to go back in time and see how it did look like back then, you can use in the latest version of NPM, you can use the install strategy equals nested option, and that would basically use this old algorithm for node modules creation in the current NPM version. And what would you see if you would like to install the React and React DOM is this nicely nested structure where this node modules was created within our package, and then just nicely structure for React and React DOM dependencies. And we can also see that the dependencies themselves of the React DOM were also nested. This can be even better seen if we install something more complicated, like React drag and drop components. In this case, we can see even more nesting, actually quadruple one. As we can see, it's going through the React DND, then the core, then Redux, and Babel runtime finally. So it's like nesting for each subsequent packages. As you can see, this nesting algorithm is it's actually that simple, but there's a small catch. Because I've been showing you the example for only one package or one project in our repo. If you'd like to make and mess up a little with our repo and make out of it a monorepo and have similar or free packages actually, and install for all of them the React, you can immediately see a small problem that we end up with 3 copies of the exact same dependency. And this, ladies and gentlemen, is the first monster that haunts our node modules, called doppelgangers. What doppelgangers are? Actually, when I was venturing through those node modules, I was able to take the picture out of them here on the left side. It was really dangerous, but I survived. And as you can see, these are really these small, pale, goblin-like monsters that really like to disguise as your favorite packages and then consume their favorite snacks, which of course is your own disk space. But joke aside, that's basically just how we call those duplicates of the packages in your node modules. And as a matter of fact, the bigger your project is, the higher chance you will catch some, because you have the more dependencies that can be duplicated in one way or the another. The biggest pitfall of those doppelgangers is basically they inflate the size of your node modules, which can reach even to 80%, and we will see this in the future. And the bigger your node modules is, the slower your install, because you have more files, they are bigger, so you're just limited for your constant throughput of your disk or network or other resources on your instance. And this can actually have the even worse snowball or compounding effect on CI/CD when you can have multiple parallel installations of these node modules going on at the same time if you're running multiple jobs on the same CI/CD node. At the same time, the bigger your node modules are, the more bloated your bundles can be, Although I'm not the expert with bundlers, but I've seen some cases where actually this was happening, that bundle was not able to duplicate some packages, and still like this duplicates were shipped in the production bundles, I mean the front-end ones. Last but not least, those packages are no longer singletons. And that may lead to really all kinds of confusing and hard to debug issues, especially if your packages are stateful. If they contain some caches or any stateful logic, then this behavior of these packages may become inconsistent depending which instance you end up calling for some maybe util library or some other dependency. Similarly, if the package has some kind of the dynamic entity resolution or injection logic, like in Nest.js, you can also harm yourself, because then, depending where in which instance of such a library you register those entities, they might not be discoverable if you call or try to discover them in other instance. And lastly, there are also duplicated type definitions, which again can harm you in your TypeScript builds. But you might say, oh, Carl, I'm not using monorepo, doppelgangers won't harm them. Wrong. And I have proof for this. So let's install and create the empty npm project and install something simple, let's say jest, using this nested strategy. Then run this horrendous one-liner, which basically all it does, it detects all packages installed in your node modules and count their occurrences. And that's what we get. Over 80 duplicates of some Babel sub-packages, over almost 19 duplicates of Pico colors, or 16 of Semver. A lot of duplicates, as you can see. And all of this making our simple project with just a Jest installation weighing over 200 megabytes, quite a lot. And if you're wondering why those dependencies end up being duplicated, you can use npm ls command and seeing this nicely structured tree explaining all the relationships between packages and see where it comes from. But you might again say, oh, you are doing some outdated nonsense. It was year 2010. We have 2015 now, man. Well, you are sure. You're right, because in 2015, actually the npm version 3 has been released. And with it, the era of flattened node modules and hoisting has appeared. And npm 3 explained this behavior or this approach in its own release notes. I will not read it because on the rehearsals it sounds pretty terrible, but it's quite complicated and vague. So let me explain this in more friendly manner. This is the repo that I've been showing you when explaining the doppelgangers for the first time. What hoisting does in this case, did it break? No, it's fine. It first creates the node modules folder in the root level of your project, and then puts all of the dependencies there. So in this case, you get those copies of React. They are deduplicated to a single instance, which is put right there. So we end up with this simpler and smaller structure with just a one instance of React, as it should be. Again, if you'd like to check it out for a little more complicated dependency like Express, which actually has some dependencies on its own, we can see that this hoisting, which I'm just presenting, is also being applied to those transitive dependencies. So actually, we can consider these root level node modules as like the big bag of all dependencies that are being used in your packet in your project, and they are being put there. But it can get a little bit more tricky. Let's assume we have the project with 4 instances of the React, but 3 of them are React 19, one of them is React 18. Well, in this situation, we cannot just simply hoist a single version of React, because we would end up shipping the wrong version to at least one of those packages. So what we can do? Well, it depends on the packet manager. In the npm, it would hoist the very first discovered version. What I mean by this is when the npm traverses your project, it basically remembers each version of each library that has been discovered first. In this case, the traversal would first go into package B, which means it would see the React 19 first, and that's what would be hoisted in npm. But we can play with it a little and break it. Maybe not break it, but show how inconsistent it can be. So let's imagine that then somebody adds a new package to your monorepo called A that goes before the B. What happens? Well, the structure of these node modules then will change. Oh, I see myself. And now the React 18 will be hoisted. So it can become inconsistent when you add the new packages. On the other hand, in Yarn, they are using much simpler approach. They basically hoist the most common version. So they are optimized for disk space saved. That's all. But as you can see, in both cases, hoisting doesn't eliminate the doppelgangers. They are still there. Some of them are deduplicated, and we are safe from them, but they are only scratching the very surface of this problem. So you may ask, is it even good if it's not solving the problem for good? Well, so let's recreate the previous experiment, as we did previously, but this time using the hoisted strategy. So we are again running this monstrosity of the one-liner, and we end up with quite nice. No doppelgangers, almost at all. Only some 4 duplicates of Samver. And by this mean, we get just 30 megabytes of the package. That's whole 86% reduction. So actually, hosting is not that bad if your project is not that complicated. And you don't have that much of these conflicts of different dependencies. If your project gets bigger, then probably hosting won't save you that much because the conflicts will be much more common and not that many versions could be deduplicated. But with the great power comes the great responsibility. The hoisting itself, because it puts all those dependencies in the root level node modules, which can be discovered by any package, actually liberalizes the way how the modules could be resolved. And this awakens yet another dangerous foe, called phantoms. This on the right side, you can see it's a footage from CCTV camera in my home when I was trying to deal with some issues on my company laptop. Those are basically the entities that tries to mimic the friendly beings, help you and making your life easier, but just waiting to strike. But just aside, those are basically the dependencies that are used in your source code, but they are not defined in any package.json. How it may happen is basically you install certain new dependency, the new at all in a whole monorepo, in one package, and then just start using it out of hand in another package without doing anything. Out of the carelessness of certain developer or just being unknown that he needs to add the package.json, in many ways it may happen. And at first, it may sound really handful that you no longer need to worry about package.jsons and maintaining them. That's great, you may say. But well, it may really hunt you in many, many ways, especially if you assume that a given package is defined in a only single place in your repo. Then, if you update its version, it suddenly propagates to your all other packages which are using this dependency silently, and may break your build for all the company you wanted just to upgrade a single package for a single project. Then you're ending up breaking entire company. Similarly, if you remove it, the same thing's happening. Package manager no longer see and can discover this package anywhere, so it will again break the all others project at the same in the same way. Or if you really want to be a dick, you can actually define it as a dev dependency. In this way, it actually will be present in your local and testing environments, because there we are installing all dependencies. But when it comes down to the production builds, then usually those dev dependencies are excluded. That means you will be actually shipping this code without those dependencies that are required. So you will build the production. Luckily, they are much easier to be dealt with than doppelgangers, as basically you just need to find them and fix manually by adding them to the package.json. So the life was really grim since 2015, but I may surprise you, but since then there was no any update for the npm hoisting at all. It's using it for the last 10 years. But then, finally in 2020, the savior we have all been waiting for has come. The true lisan al-gaib of the package managers. Oh, it doesn't work. the PNPM, which stands for the Performance Node Package Manager. It was created actually in 2016, so only a year after the NPM announced its hosting approach, but didn't get much traction until 2021. Which can you see actually on this chart that I prepared, where I scrubbed the information about the packet managers used in top 2000 JS and TS repositories on GitHub. You can see right now it's around 20% of the market share, while back in 2021 it was like 1%. What's special about the PNPM is that it's not using any flattened modules, nor the hosting, but instead it's using the unique strategy based on symlinks. And this way, it actually gets rid of the doppelgangers and phantoms for good, at the same time being faster and more space efficient than its alternatives. In terms of the benchmarks, here we have some data. The one on the right side is actually the official benchmark for PNPM, made by the people behind it. You can see that it's pretty much always a lot faster than NPM, sometimes in par with the yarn, sometimes slower, sometimes faster. But what I prefer to trust is actually the benchmarks from our own monorepo, which we recently migrated to PNPM from yarn. In our case, it allowed us to decrease the install times, for the clear install times without any cache or node modules, from 3 minutes to 1 minute, so it's a huge drop. At the same time, halving our node module size in terms of its own raw gigabyte size, as well as the amount of the files that's within it. But how PNPM does it? So let's see what would happen with our package structure when we would install stuff with the PNPM. So let's start with installing the React 18 for package A. What would happen first is that PNPM creates something called global store or repo scope stored within this root level package in the node modules. But there's a small catch that is it's storing it under the dot file, which actually is not discoverable through node module resolution algorithm. So any package that would land there will not be visible for node. Then we put all those packages there, installing, reminding about the versioning itself as well. So it's not like in the normal node modules where only the name of the package is maintained. No, we also remembering about the version itself. And then, in order to make this package resolvable from other package A in this case, instead of copying those files, dependency files, straight into those node modules, instead we are creating something called symlink, which basically is this kind of the file on our file system that instead of storing its own raw content, points to the another file. And this symlink, in this case, points to this React instance stored in the PNPM store. Then, if you would like to install the React DOM, very similar happen would go on. This React DOM would be put first into our global storage, as well as its own sub-dependency. As you can see, the very own node modules of the React DOM is also structured just like the other package using the symlink. So there's no duplication on this level as well. And then the same what we've seen for the React itself. This React DOM is linked through symlink. Then if you would like to install both packages for B, we would not install anything on the global level. We will only create these symlinks. And lastly, if you would like to install some conflicting package like React 19, there will be no issue at all, because still they will be put into our global store just with different naming, so there will be no name conflicts. And then again, we are linking it. So what are the real benefits from this approach? First, there are no doppelgangers because we are installing every and each package just single time. We are actually doing this in the most space efficient way because we are only installing these dependencies which we need and doing this one exact time. Then there are no phantoms because we don't have any hosting here. Each package has its own node modules filled with the dependencies that are only defined in its own package.json. So just to end my talk, a few tips from me how you can ditch your hosting and use symlink approach instead. So first, you should choose your fighter, because actually all node package managers currently implement the symlink-based strategy in one way or the another. In case on the npm, it's called the install strategy linked. It's in experimental stage for 2 last years. I haven't used it, so I cannot really talk much about it, but you can try it. In case of Yarn, it's in the stable release. From my experience, it's okay-ish. Actually, when I was migrating our monorepo to Symlink, I first started with Yarn, but then got pushed back with nasty bugs, so we end up using PNPM itself. And from my own knowledge and experience, for the last couple of months, I think that PNPM is the best choice, the most reliable and configurable, and the most maintained, the mostly active maintained. The second thing that I would advise is to separate tool migration from the linker migration. What I mean by this is that if you decide to, for example, go from Yarn to PNPM, you may first consider moving just your CLI tooling from Yarn to PNPM. So if you're using the hoisting in Yarn, then go to the PNPM with hoisting, and only then take care of the linker migration when you're already within the PNPM ecosystem. It can just save you some additional work, just making this work in parallel instead of doing everything in one big bang release. Yeah, that's what I just said. But you need to watch out, because when you are changing the packet manager, you will need to generate the log file for it from the scratch, and you can silently end up updating tons of dependencies which weren't updated previously. And then, in terms of the strategy migration, you will need to first fix the phantoms and doppelgangers, because if there are any phantoms in your project, and then you migrate it to the PNPM, they will no longer be resolvable. So we need to take care of this first. In case of the doppelgangers, actually I lied to you, because symlinks do most of the work for you, but you may be interested in checking out the due peer dependence option in PNPM, which all it does is taking out the potential problems with peer dependencies out of the picture. And in terms of the fixing phantoms, well, that's a lot of more work, because basically each and single one of those phantoms need to be found out and fixed manually, meaning adding them to the package.json. So this can be a lot of work, but again, I have a couple of tips for you. First, you can check out the depth check tool, which basically what it does, it scans your source code, it imports and comparing them with the content of package.json, so you can check out which packages are missing or actually defined in the package.json while they're not being really used. And this should fix most of your problems. It will just end up with like some edge cases like plugins or packages imported dynamically and so on, which are actually the hardest part of the migration. That might sound really simple, but you can also consider using agentic LLM to automate your work, because the previous part requires a lot of the repetitive work. Just tell the cursor to do it for you. Just give it a few steps what to do step by step, and it really will do the great job for you. And use your own time to tackle more complicated and challenging cases. And one more important thing, if you have a problem with the phantom dependency and you don't know what's going on, always check the upstream package, because you'll be surprised how many of the NPM packages are actually published with once. And I'm not lying. If you check some issues on popular packages, you can see a lot of people annoyance about some dependencies not being defined yet used. So always check this and just compare if the thing that the runtime is complaining about is actually defined in the package.json of the package. And last, some approach that actually came up on Friday's evening. If you really don't know and you are just lose your mind which package is missing because it's just too vague and those errors are just too unreadable, you can use the bin search. How? Basically, what you can do, if you have a command that is failing and you want to fix it, and you know that the root cause is the phantoms, you can take this command, generate hoisted node modules, sometimes on the site, and then copy this folder somewhere between the root level node modules of PNPM and the package you want to solve. This way, you will make those hoisted Node modules discoverable from the Node runtime. And now you can do the binary search for the content of these injected Node modules you just did. And I believe everybody knows how the bin search works. You basically split it by half, checking the result of your comment. If something changed looking like it's fixed, then perhaps this content that you have in your these injected Node modules perhaps are storing this dependency that is missing. And you go on until you find out just a single dependency left in these injected Node modules, and this should be the one that you're missing. If you're a little confused, go out and check my own implementation that I did and actually used during the migration. So go ahead. And that would be it from me. Thank you all. And there are also the link for the slides if somebody wants. I probably should generate the QR code, but yeah, thank you.
Wow, that was lovely. Thank you so much. I always don't leave just yet. We'll probably have questions for you.
Okay. I just want to drink.
Yeah, of course. That is really important. Stay hydrated. Yeah, don't turn it off. Right. So it's like when I talk to people from different sort of areas of programming, it's like, oh yeah, JavaScript is crazy bloated with the node modules and many gigabytes. So it's like, yeah, if you compare it to something like Cargo in Rust or just Go Get, where the sort of package management is built into the language itself, I was like, yeah, it's pretty bad. But if you compare it to something like Python, which is crazy to me, like the default, I'm so sorry, the default dependency management mechanism does not have a log file, which is insane to me. Anyway, I just wanted to rant. Do we have any questions for Carol? Please go ahead. You can take my microphone.
Yes, thank you. So first of all, a really nice presentation. Yeah, you put a lot of effort and it can be seen. My question, did you try to use ban as a package manager? Because it's, from my experience, also pretty nice.
I was expecting this question, so I prepared. Actually, ban and also Dino, because it's a little bit a similar topic, it's something else than the packet managers. That's a different runtime. You need to remember this. Because Node is its own runtime, Dino and ban is its own runtime. But it's also the packet manager itself. So it's a little bit different topic. And actually, from what I know, for example, the Node documents real well how it discovers and resolves all those Node modules. You can go out in the documentations for ASM and CommonJS modules. There are these step-by-step instructions how it's being done. It's not documented for ban, so I don't know how they do it. So this gives me a little bit of fear of moving out, because it makes things that are not compatible. But from what I know, how the ban achieves like those deduplicated packages, because it does something similar as the PNPM. So it has this global store, but instead of doing symlinks, it's actually doing those symlinks in the runtime. So instead of storing them in your Node modules, it's discovering them during the runtime. So I may assume that some of this work may be put into the runtime, and it may slow down a little bit of application. I don't know. But that's my insight of how the ban works. Did I consider moving it? Not really, because I thought that it's a little bit too much work and too much of the paradigm shift. But maybe we will do in the future.
Just Just want to mention that ban can work just a package manager and without this runtime things that you mentioned. Yeah, just create like npm and etc. So actually you can use it without any.
Actually, I didn't actually know this. I thought it's the other way around, that you can actually use the Node packet managers with ban. But I didn't know about the other way around. But it's good to know. So thanks a lot.
Perfect. Do we have any more questions that are actual questions?
So I use the newest version of PNPM, and I think it does something also a little bit different to
hard links or hard links or not?
No, I think it combines the names of different packages, and this is how, like, you end up with like weird names of packages in Node modules. And do you know why it does it and,
Yep.
and so on?
Actually, I've omitted this part on our presentation because I consider this would just be a little bit too long. What you just described is basically the side effects of pure dependencies. I'm not sure if you know what's that. The pure dependency is basically the dependency of the package that the package says that I don't want to install it by my own, but if you want to install me, you should have it already installed. It's usually used when you're implementing the plugins that should like monkey patch or hotload certain stuff. And those stuff that you're seeing in the PNPM, those additional packages, are basically definition of those peer dependencies that are being shipped with this version of dependency. But actually, you can mostly get rid of this problem because those peer dependencies actually can generate the doppelgangers if the peer dependencies versions mismatch. But you can get rid of it with this function that I presented previously. The due pre-dependence. If you use it, then you will always, or mostly always, end up with just a single version of each package. Nonetheless, the pre-dependencies are.
Thank you. I'm afraid we don't have time for more questions, I'm sorry. But please feel free to reach out to all the speakers during the break time and wherever you feel like. They're, I assume, here to answer our questions, right? Not just here. All right. Yes, yes. Thank you so much. It was lovely. And with that in mind, I invite Jakub to, you have your own laptop, or it's all prepared? Perfect. Right. In the meantime, I just wanted to mention that there is a big problem in the JavaScript ecosystem with all the sort of massive dependency sizes, and there's actually a fairly nice initiative amongst there's a bunch of cool people from the JS ecosystem, but what they're doing is they're trying to replace all those heavy dependencies that millions of people install daily. And the initiative is called E18E, which is short for, as in the internationalization thing. It's the same for ecosystem performance. So it's e18e.dev. This is where you can find a lot of information about all the efforts, and people are actually going to different super popular packages and replacing the dependencies that are dependency heavy with sort of simple dependency free alternatives, which I think is pretty cool. Right, so we good? Yeah, there's still some downtime. I can dance around and say something. Do you like the weather today? Who here prefers the hot weather over the weather like this? Really? Okay, so we have two people. Yeah, everyone's just stopped. Oh, yeah, you're ready. Right. So shame to the hot people from me personally. I don't judge anyone, but a little bit. I do judge a little bit. Who likes the hot weather? Right. Anyway, please welcome Jakub on stage. Thank you.
Thank you. Thank you so much. Today I'll be talking a little bit about Blazor WebAssembly, which is framework designed by Microsoft. And when I was preparing some slides yesterday, I asked one of the LLMs to verify what I did. So he politely suggested that maybe I should remove some slides, so it will be not as big as I planned, because I don't want to be that presentation a tutorial. And I want to shift that my focus to architecture, really. I want to discuss how this approach is different from what we know on our daily basis. Nobody's running, so good sign. A little bit about me. My name is Jakub Grzywaczewski, and by day I am a full stack developer. By night I am WebAssembly, Netflix consumer. And also I really like reading and okay, cool. Yeah, I invite you to go to my blog, Memory of Light. I really like prose of Robert Jordan, Wheel of Time. And if you want to connect with me, this is my LinkedIn. So yeah. Okay, new kids on the block. And some time ago, when I was working in one of the fintech corporations, I was meant to work with a framework I didn't really like, and this framework was called Vaadin, and it was really different from what I knew at the time. This framework doesn't use much JS, really. You have to write your all code in Java, and it brings a lot of, let's say, problems when it comes to debugging, especially when you need to check why some listeners are not removed, and you need to still connect your business logic with which is located on server with the browser. And it's hard to believe. Initial release was in 2009, so many years ago. I haven't even started my career at the time. And except the Vaadin, there are a little bit more frameworks which arrived after 2017, I think. Do you know what happened in 2017? Precisely. And what happened then, the people who were who like really the languages they work with, like C#, I mean, it was Microsoft, but people who are created U, which is basically using Rust, they figure out that maybe we can actually create some framework which will be working on the browser, but still you can write your business logic, your whole code base in your favorite language. So why not? And how it works? Vaadin is a little bit different story because it happened before WebAssembly, and Java developers really like working with servers, so they people from Scandinavia, I believe, created that framework, which was just using basic HTML, some JS runtime, really tiny one, and web components. They provided even the whole repository of web components you can use basically in your application. And yeah, you can easily create some back office apps very fast. But with you and Blazor, I was working with both of them. There is this small difference, WASM. And for Blazor, we'll be talking a little bit more later about it, but you just need to remember that it's HTML, it's the runtime wrapped inside the WebAssembly, DLLs, and JS bridge called JS interop. Similarly, it works with you when you have your build of your app inside WASM container, and also very minimal JS bootstrap. Have any of you was working with those frameworks? I'm just curious. No. Okay, cool. Even better. So let's move back a little bit. How this normal work flow of getting and unwrapping the JS codes you send to the client works. So this is the classic JS flow. It's simplification, but it works more or less the same as you can see here. So first of all, you're getting a JS file, plain JS bundle, and what is happening then? The browser needs to parse that file. Usually, in simple applications, it's not a big problem, but sometimes these bundles can be really heavy. And the process of reading that file, basic checking, it's called parsing. After parsing is done, you are going to the step number 2. You need to build abstract syntax trees. So basically the structure which will be used by compiler or can be used by linters is very useful after all. So once you have that, you can compile that what you unwrapped from that bundle and compile to bytecode. And there is here it comes GIT optimization, and this is when things are actually interesting. GIT means just-in-time compilation, and just as a reminder, how it works. It's like you are getting your code, and the compiler is reading that and trying to execute, interpret and execute at the same time. So it can easily read which parts of your code actually executed more than once. And based on that knowledge, it is quite easy to decide, should I spend a little bit more CPU cycles on compiling that code, and maybe it will bring some speed up when it comes to execution, or just leave it as it is? And when answer is yes, the compiler will compile that code you get from JS, and it will compile it to machine code, and it can really speed up because it will be directly executed by CPU. And then there is last step, which is just execution. Okay, so what's the difference between what I just described and things when you're using WebAssembly? So WebAssembly flow is a little bit different, and we have that concept of streaming compilation, and this is actually not the same like GIT, because you are not getting JS bundle, you are getting binary wrapper, which is called WASM. And what benefits it brings is basically you don't need to parse it. Parse it can be expensive. Parsing can be expensive, and the streaming compilation can do actually, for me, magic thing. So once you have this file coming to your browser, the compilers can start decoding and validating at the same time when it's still in the process of downloading. So when the head comes to the browser, compiler starting the coding, some short validation, and when the headers and imports are in the browser, it just initializes the module, the whole module, and yeah, after that, it will just execute that code. It's possible that the first, chunks of your code will be executed before even the whole thing will be downloaded. So what's so special about WASM? And here's a definition. It's a binary format that's compiled ahead of time. So before you will use your code, you need to compile it. So it's quite beneficial when you want to put some heavy operations in some, language that it's more performant than JavaScript, and in the format which is more performant than your browser used to. So it's actually interesting about WASM, that it brings near native performance. So for me, when I read that about 2018-17, I was really surprised. And actually, one of these creators of that WebAssembly project said if it would happen before, let's say, 2010, possibly Docker would be so big thing after all. So yeah, and what another great thing about WASM is that it's language agnostic. you can write your code in Rust, in C#, in JavaScript if you want it, Dart, Go, name it, and it will be just as good as it should be. Also, because it's language agnostic, it can be also portable and compatible with a lot of architectures. And last but not least, it should be as secure as JavaScript is. So we are basically using the same content security policy and also the same sandbox we are using for JavaScript. And here you have some comparison between JavaScript and WebAssembly. I found that a great tool for making benchmarks, and here you have a link to repository, but you can see that for more complex tasks like some matrix multiplication, calculating primes, WebAssembly would be just better solution. So there are any drawbacks in that perfect world? They are. And first of all, when it comes to build web applications with WebAssembly, you cannot do much really. You have your business logic, it can be executed, but how you will deal with DOM updates, how you will deal with BOM, you still need some middleware here. So all of that frameworks, as you maybe remember from previous slide, requires some JS interop. Because it requires JS interop, complexity actually is involved here. Initial payload, it can be really painful because it will be really heavy, and 1 to 3 megabytes, it's not the worst I've seen. So you usually have to enable some performant compilation. I will show you what the difference is in some live demo. And possibly you need to consider using lazy loading and compressions. Of course, there is not the most painful, but there is still here garbage collector is still limited a little bit. Debugging is much harder than in just JS because you don't have JS. You have your own code you wrote in maybe in Rust, and you have this middleware which is called JS interop, and you have your WASM in your browser. So good luck with that. And when it comes to Blazor WebAssembly, you may ask yourself, why Microsoft chose WebAssembly really? And this is actually strategy I really like because it brings progressive enhancements, no plugins required for building those apps, the same security model, and most of all, one stack story. And they want to have C# everywhere. So why not in web? And of course, one of the greatest benefits when it comes to building Blazor applications is that you have a very robust ecosystem. You can use Visual Studio, which is very heavy IDE you can use for building desktop apps, for building servers, and now Blazor brings that to web. Okay, I said that Microsoft invested a lot of time to building that ecosystem, and as you can see here, WebAssembly it's just one of the Blazor parts. So Blazor is the whole ecosystem. They have Blazor server, which was, I believe, the initial release was when they created actually Blazor server in 2018. And it means you have a thin client and you do a lot of stuff on your server. It's quite fast. But when it comes to building single-page application, it's really not something you want to choose. So they came up with idea of building WebAssembly, Blazor WebAssembly, and it was released in very early 2020, I think. And it's just the framework you want to use when it comes to building fat clients, a lot of interactivity and things you want to have just in your browser. They also created Blazor Hybrid, which is just for building desktop apps or mobiles, and something called Web App, and I think it will be renamed or replaced, I don't know, by Blazor United. So you have a mix of Blazor server and Blazor WebAssembly. How it works, initial load, it came from server, because when it comes to WebAssembly, you have to download it. It takes time. So you will get pre-rendered website from server, and in the background the WebAssembly will be downloaded to your browser, and you can enable interactivity. So, what is Blazor WebAssembly in one sentence? And this is a quote from Microsoft Learn. Blazor WebAssembly is a single-page app framework for building interactive client-side web apps with .NET. So, yeah, pretty dense, and I really like that they created the framework, because it just I think a really nice idea to bring WebAssembly to the browser. And yeah, so I wasn't sure if I can show you today anything on my laptop, so I prepared some slides with some explanation how this project is structured. And so I will switch to the my editor. Yep, this is what I wanted to show you. Yeah, let's take a look at the beginning on the project structure. I will increase maybe some font. So as you can see, there is a project called demo. You have a lot of files with an extension called Razor. And Razor is just like JSX in React world. So if you want to build a component or page, you want to use Razor extensions, except that you can see this is basically created from scratch from the tool they provide. It's really easy to create these applications, I mean hello worlds. You will see that when I launch it, except that we have some configuration files like SLN, CS project, or it should be something like app setting somewhere. And yeah, this is basically what we have also in JS world, so package JSON, bundler configuration, webpack, and so on and so forth. And they provide also the structure, which actually solves a lot of problems when it comes to designing the structure, when you want to put your pages, how the routing should working in your application. So they provided folders, layout, and yeah, the most important part here, I mean component here, is appraiser. It's just index HTML, index.js, so the root component when you will put some authorization and so on. You have also imports Razor and some components like here. Now I have to I just want to show you how this component looks like. And this is really simple counter component. On the top, there is a directive page, so this just says that it should be found under that URL. You have page title, which will be displayed in the browser, in the tab, and then you have just normal HTML code. It's not JSX, it's just HTML code with some additional directives. And below, you can see normal, simple C# code. And I'm going to start it. Okay, hello world. It's just hello world app they provide with that the .NET tools you can use to create a project from scratch. And yeah, you can see that we have that counter. You can click me, it's just working as it's supposed to be. I have some typos here. Yeah, and this is basically how this whole thing works. It's not a devil, but nothing interesting so far. So going back to the presentation. Okay, I will speed up. Okay, so we have additional folders, object and bin are additional places where if you are interested really in this, the whole architecture and where the WASM exists, when you have some cache and your interop, you just want to go and dive to these folders. Yeah, I said at the beginning that the Blazor requires some additional helpers, and I said it uses JS interop, but how does it really works? How the code is executed? The Mnemono is a runtime designed a lot of years ago just to enable .NET to run on Linux and on macOS, and it's just used here. It's just wrapped inside WASM, and Mono runtime is compiled into WASM, and it's enabling C# to be natively run in the browser without any plugins. Okay, so I showed you that page before. You can go to this demo code on my GitHub page. Yeah, and the interesting part here, you have C#, you have JS interop, and how this really working. You have that middle in between, right? The runtime, but can you actually invoke code from JS code from Blazor? Yes, you can. You can invoke C# code from JavaScript. Yeah, it seems you can. And in this demo, you can see if you go here that we can easily execute it. So we have calls from C#. It will be executed, and at the same time you have here a console log, and you can execute C# from from JavaScript. I will speed up, so I won't be diving into this this code right now, but I can, if you are interested, you can go here to interop component, and you will see how all these things works. It just contains some asynchronous methods which can be invoked in both directions. And as well, you have www root when you keeps your JS interop. And yes, you have JavaScript with Blazor. So when it comes to Blazor, you don't have just C#. You have your WebAssembly runtime and also JS middleware called JS interop, but also you have to provide sometimes a lot of JS. And it's quite normal if you have package.json here with the whole setup and npm packages. Going back to the slideshow. Yeah, we have also component cycle, and as you can see, you have a lot of methods here. Basically, we have three phases: initial, update, and dispose. And sounds familiar, right? It's the same as in React before hooks. So the key takeaways from that presentation I want you to have is WebAssembly solve some problems with parse and GIT sailing. You can read here in Almanac in section of performance. So yeah, Blazor WASM brings C# to the browser without sacrificing the JS interop. So you can have both. And yeah, interop keeps JavaScript as a first-class citizen here. It's not JS replacement, it's just, in my opinion, extension, which can bring you a lot of good things. Thank you.
One, two, three. Oh yeah, thank you so much. It was kind of a fun thing to see the components in Blazor, that reminded me a lot of Svelte and Astro for some reason, which is kind of a similar-ish style of mixture of code and the markup itself. Right, do we have any questions? We have time for exactly one question, the very quick one. There you go.
Hey, thank you for presentation. Just wanted to know, I saw this full presentation and still do not understand where exactly it can be used. Yeah, do you have any real-world examples of using such a thing?
Yeah, and the key factor here will be your project, what you want to achieve. If you need some additional performance in your web application, so because you can create very performant code and wrap it in the WASM. So if you have some, 3D processing and so on and so forth. And Blazor gives you a lot of choices here, so you can create this Blazor WebAssembly app. But when it comes to different types of Blazor, you can, if you want to build, desktop application and mobile app, you can use Blazor. If you want to create some, even e-commerce, it will be working as well, I think. But for me, from my experience, if you have .NET developers in your team who can guide you sometimes when it comes to building more performant code, it's a key factor, yeah. And yeah, if you have .NET stack, you want to migrate from some legacy, it's also a good choice. From my perspective, it wouldn't be my first choice when it comes to creating blog, right? But when you have back office applications, when you have some applications you want to give your clients and you want to wrap some additional features, code, for any kind of reasons you can have, it's your actually a good choice as well, I think.
Okay. Excuse me. One very quick remark. We have a question from our YouTube audience on the stream, which Chris will promptly read right now.
Yes, hello. The question from M is, what are the hardest types of bug that are specific for using Blazor in C#?
Honest question. I think when it comes to debugging, these tools from .NET, connected to .NET brings you a lot of features you can use for debugging. But if you have complex application and you have, let's say, I haven't showed that, but there is here in this demo application the comparison between calculating some prime numbers in JavaScript and in C#. You will see some problems, and if you will launch, just simple .NET, runtime in debug mode, it will be not much performant. It won't be good at all, I think. You need to calculate how much you want to put effort to compilations. And I created in README the way you can compile the same code, and you will get more performant solution here. So from my perspective, performance is the most problematic.
All right. Well, thank you so much. And let's give him a hand. Once again, thank you. That was lovely. Wow. I was always so curious about Blazor and pretty much just about anything that is not JavaScript to be run on the client side. Anyway, so with that in mind, we have until it's time for the big break, and we have until 2030 to enjoy pizza, which is just behind of you. If you turn around, yes. And yeah, see you in roughly half an hour, just a bit less than half an hour. people are starting to. This is always on any conference, meetup, on whatever it is, any social gathering. It is always the biggest responsibility. The hardest slot is after the big break, where people are just enjoying their pizza and the networking. No one's gonna come. They're like, yeah, talks is because through like the thing is that usually people enjoy networking more than anything else, and this is incredibly valuable asset to our lives is to just gather around and talk. But I'm actually looking forward to the No Vercel talk. It's gonna be exciting. I like Vercel. It's a nice company. They sell triangles. They acquire companies. Recently, they bought Nuxt Labs, which is pretty crazy to me, and they hire all the best talent, and then all the best talent is in Vercel. What can we do about it? Right. So we have quite a few people gathered. I suppose this is a really special talk because this is a joint talk. We have more than one person presenting at the same time, which is crazy. I love these kind of talks. We have, once again, trying my best, we have Patrick Wojnarowski, and we have Adam Holewinski. Perfect. Give him a hand. Now they're going to talk about Vercel. Why is it bad? Is it good? I don't know. We'll find out. Go ahead. The stage is yours. That's the microphone. Do you need this one?
So, hey everyone, my name is Patrick, this is Adam. I have my notes here, just so you don't think I'm scrolling Twitter while presenting. We're gonna talk a bit about hosting, both on serverless platforms like Vercel, and doing the setup yourself, and what are the differences, and we're gonna show you a pretty cool setup. Thanks. We're gonna show you a pretty cool setup, in our opinions. So maybe before we begin, has anyone here heard of Nix? N-I-X. Ah, nice. We have a few people, nice. Okay, so let's get started. Okay. Say you want to deploy a web app today. Well, it may be your first choice to go to one of these providers. Vercel and Netlify for the front end, and Firebase and Supabase for the back end, if you need one, if it's not just a landing page. That's cool. There are many advantages to doing it this way. For example, it's very fast. You can just link your GitHub repo and see the projects online. So you can send it to people, get your first customers. It's easy and fast. Second of all, you don't have to have any prior knowledge, and you don't have to spend time learning stuff that you may not want to learn or never need again, and just to set up a server. Third of all, the iterations are quick. I mean, you just git push and see the changes. It doesn't get really better than that. And lastly, the pay-as-you-go pricing model can be really beneficial. This comes with many limitations, though. For example, the unpredictable costs that come with a pay-as-you-go pricing model. That's combined with it's not always being clear how the price is calculated. We know that it's compute and some bandwidth, but how exactly, we're not sure. And the pricing can change rapidly. If you're not staying on top of it, you can get surprised with a huge bill. So another thing is how limited those platforms are. Say you want to use a database that's really good for something, or any software at all. You either have to wait for your provider of choice, like Vercel, to integrate it and adopt it into their platform and let you use it, essentially. Or you have to rent a server and host it yourself, in which case you're back to us. Or you have to find another serverless provider that offers it. And this way you can end up with this web of third-party dependencies, like, for example, Vercel for your front end, Firebase for your backend and database, and something for auth as well. Everything has a different pricing. Maybe you use a different tier. It can just become a mess. So a good example of that, ClickHouse. At Diallo, we use ClickHouse. It just lets us scan through lots of data very fast. And they have a serverless model. So let's check it out. We'll just go with the basic tier. You get 1 terabyte of storage. And here we have a pricing calculator. So yeah, it's a bit hard to see. So maybe I'll say we chose 1 terabyte and the cheapest compute, which is 8 gigs of RAM and 2 cores. And it's always on. And that comes out to $162 a month for your database. So let's compare that to bare metal. This is a screenshot from Hetzner. They rent servers. And let's, to match Warsaw's compute, let's get the second cheapest option at $759 a month. That has 4 cores and 8 gigs of RAM. But we still need the storage. So let's get 1 terabyte, just as we had on Warsaw. And that comes out to about $50 a month. So putting that together, that comes to just shy of $60, and we have 2 cores to spare. Now, comparing that, it's hosting this ourselves saves us $100 each month. Not only that, on Hetzner, we get a server, so we can host our project there. And many others, in fact. 4 cores and 8 gigs of RAM is plenty. On ClickHouse, that's just the cost of storage. So why shouldn't we self-host? I mean, it's cheaper. It's we have more freedom. Why? What are the downsides? Well, they're right here. There's lots of stuff you have to do. A lot of stuff you have to remember and learn. So, for example, to get a basic app running, so first you have to make the app. Okay, it looks good on localhost, so you compile it or bundle it. You have to get it onto the server. Maybe you want to run it in the background, so you use systemd services. What's that? And you have to use their configuration language that's not used anywhere else. Same story with Nginx, configuration language that's not used anywhere else. Maybe you want to use Docker, Docker Swarm, Docker Compose. What are they? Which one should you use? It's a mess. But it doesn't have to be. What we're going to show you today is a setup that uses just 2 tools to manage everything. One of those tools is Nix, and the other is Kubernetes. But Kubernetes is really more of a platform where we will host our stuff. So really, we end up with just 1 tool, Nix. Everything from building our project through configuring the server to deploying can be done with Nix. So first, let's maybe check what it looks like to deploy Kubernetes without Nix. We'll be looking at K3s, which is a simplified Kubernetes distribution that handles some stuff for us out of the box. And the first thing you always do is look at the docs. OK, so here they lecture us about configuring a firewall, unless you use a different firewall, in which case you do that. Here they say we might need an external database if we want it to be production ready. I guess we do, but maybe we don't really want to do that. Here they just give us some shell scripts we have to run. Now, I'm not exactly a fan of running strange shell scripts I found on the internet, but it's K3s, so maybe we'll trust them. And oh my god, danger. Well, now I really don't want to use that. So why can't we just do something like that? Well, it turns out we can if we use NixOS. NixOS is a declarative and reproducible Linux distribution. What does that mean? That means we just describe the state of the machine that we want, and NixOS will handle the setup for us. So we can just write that we want the service K3s to be enabled, and Nix will do that. So what does that look like in practice? We have a demo here.
Mic holder.
This is a fresh NixOS VM.
I'm not just here for holding the mic. I will be talking.
We promise. This is a fresh NixOS VM. Basically, right after install, you'll get something like that. So let's just go into the directory in which NixOS is configured. And you can see we have two files here. The entirety of NixOS can be configured with just those two files, but the hardware configuration you see gets generated for us, and we never have to look at it. NixOS generates it when it's installed, and you never open that file. So really, we have just one file. That's the configuration.nix. So that's what it looks like. The only thing I have added here is some Git and an editor. It will look something like this right after you install. So let's do exactly what we saw on the slide. Oh yeah, I can see.
We can't.
Something with the software we use for VMs, it doesn't let us, I think. Yeah. Unfortunately, I'm gonna have to talk about what I'm doing. So right now I'm typing in the word services dot k3s dot enable equals to true. Saving and exiting. And now we have to run one command. That's just to let NixOS know that something in the config has changed. And once we run it, Nix will evaluate the config, get everything we need and everything we want, set it up exactly how we told it to. In this case, we didn't tell much, so it's just gonna provide some same defaults. And we should end up with K3s installed. So it's done. Let's check. The command doesn't matter, but you can see it's green. Green is good. It's enabled, it's running. But that's not the only cool thing we can do that Nix allows us to do through its declarative setup. We have made a blog for this presentation. This is just the GitHub repo for it. You can check it out. Oh, not my keyboard. At easybaremetal.com. If you're interested, there are some tutorials here, and it goes into much more in depth than we could have because of the length of this presentation. So for the repo here, let's just go into a directory in which I have the config. So let's check it out. This is a config on Git. That's a good point. And so here is basically the same config. It just has a few more packages like Calce and Beatup. Just to confirm, we don't have them right now. It says command not found, if you can see, and the other one as well. So now we can run the same command we just ran before, but we can specify to Nix where it can find our config. And here we'll provide it a path to GitHub. And optionally, you can give it a directory. So now Nix, thanks. So now Nix will first go to GitHub, get the config, and then do the exact same thing. This is great if you want to, for some reason, change servers. So maybe let's say your server provider suddenly raised its prices by a lot and you want to move. The only thing you have to do is get the config out of there and onto your new machine. So we didn't have those packages. You can still see at the top. Well, maybe you can't, but I promise you it's there. And if we run the same commands now, we have them. Same thing for the other one. It's there. Okay.
All right, that's me now. Let me change it to the, where's the presentation thingy? All right, so that's nice. I am also not scrolling Twitter. I'm changing to my notes. So that's nice. We have, I should be in the camera, I guess. We have our Kubernetes installed, deployed to NixOS, and that was very easy, just one line. And to move on with this presentation, we want to do everything with Nix, not just deploying Kubernetes. So I guess we should kind of talk about what exactly happened there. Well, maybe not exactly what NixOS did, but how did all of this happen that we just declared something and it magically changed our environment? And well, NixOS is a Linux distribution based on Nix, and we will do everything with Nix. So let's talk about Nix. And Nix is a massive thing. I don't think I know everything about Nix, and I use it quite often. I don't know if anybody knows everything about Nix, but you might hear from tutorials and stuff that Nix is three things. It's package manager, programming language, and operating system that you just saw a second ago. And it's indeed those three things that are strongly connected with each other. But for now, I want you to think about Nix, especially for those who never heard of Nix, that it's a tool for creating declarative deterministic software environments. So let's decode that with a simple statement, with a simple example. Say you're building a JS app, you have a project with some JS app, some front end to bundle or anything, and let's inspect the like a stack of dependencies. So first you have your JS dependencies that are listed in package.json, and you have the log file from whatever package manager you're using. So that's great. We have a log file that's pretty consistent. So that's cool, but we need to run it with something. So say we use the Node.js runtime, but this also has some version. So I guess we're using NVM for that, for example, Node version manager. And we might also have some external dependencies that are needed either in the runtime or development time, some external binaries. So I guess we're using Homebrew for that on macOS or some other package manager on whatever OS you are developing on. So we don't have a log file for those things, and we don't really know what version should we use exactly, and we need to like know in our head what version of Node to enable, I guess. So to know the version, I guess we is it changing? Oh, we need to look into our documentation, or maybe call our friends if we have some. So let's look at what we do with Nix in this scenario. We have our JS dependencies, that's all right. We have the log file, this is consistent. And everything else is basically done with those two files, and one of which is also a log file, but it's a Nix log file. And this is basically Nix, which is describe everything we want in our environment with the flake.nix file in the Nix language. And Nix will prepare that environment for us, and whether it's JS runtimes or some other external dependencies or environment variables, whatever we need, we can describe it in Nix to build our application and develop it. And even if you have multiple projects or applications on your machine, or you're building multiple applications on one machine, those environments are totally isolated from each other. And this kind of looks like a Docker image, like an isolated environment with its own dependencies. And you can indeed build Docker images from those Nix environments, Nix declared environments. And this is definitely the Nix environment, the software environment that Nix creates is definitely not a Docker image, but because it's so deterministic, you can build Docker images with Nix. So just to see that in action, let's maybe take a look what a flake looks like. On the right, there's some Nix language, but it's basically like a JSON with functions. And the most important parts are the first inputs, which are just really like imports of repositories where you fetch your packages from. Then you get some outputs, which is actually a function, which this colon, a little colon there means a function. And basically on the left you have the argument, on the right you have the return values. So on the left we have all of the packages that we set in the inputs that we want to have, and what do we return. And this is probably the most important part, that we have packages, and there you list all of the packages and apps you're working on. So for example, you describe to bundle some front end from your source, and you're describing the whole app, and then you trigger it with Nix build, which results in some directory. It just gives you some directory with the builded stuff, or a file if it's a file. It depends on you. And then we got dev shells, which lets us describe a development environment that we want to have for developing those projects. So it's pretty common to like use the same packages that you use in the packages that in the app you described in the dev shell, and you trigger dev shell with Nix developed, and this opens up a new batch with all of the dependencies in your environment. But let me just show you that in action. I think it's more cool in action. Sorry? Oh yeah. Here's my mic holder, and let me just open up. This is the repo actually that you saw in the browser. Let me just open up a simple flake, and let me open up the terminal. Can you see everything, or perhaps? So as you can see, we have some inputs. This is the official repo of Nix packages. There are paths here. Those inputs are here after resolution. And those are the things we care about the most, the packages and dev shells. And let me show you the dev shells first. We make, with this function, we make a simple, very simple dev shell. We list some packages that we want to have. A shell hook is basically just a bash script that runs when we enter the shell, and some environment variables. So right now in the terminal, let me just delete that. If I enter the shell, if I actually first try to print out the editor variable, it's neovim. And if I try to use node, I don't have node here. But right after I type Nix develop, Nix will create a new environment for us, enter a new shell. This is actually pretty not good looking shell, but this can be fixed. And now, if I type node, I suddenly have node, and it's the exact same version I specified here. And if I try to echo the editor variable, it's suddenly helix, ajax, which we specified here. And if I leave this shell, try to use node again, I don't have it. So this is great for developing the project with the exact environment that you want to use, with the exact packages and dependencies you want to have. And it's the same stuff for packages, it's just that it builds something for us. So in this environment, it doesn't enter this environment. So we use here like a almost built-in function to build npm package. So this just bundles some basic front-end, I think, from the source. So if I run Nix build with the name sample app, it will give us actually a symlink to a magical place called the Nix store, but it will, when we browse this result directory, it will have all of the things that we specified here that we want to have in the build in the public directory. So everything that we need to build our application. So that's cool. Let's move on with the presentation. Oh, just two? Oh, okay. Can we have 4? Okay. I'll try to speed up. So this was Nix. I'm gonna go with a. This is like a fun fact which surprised me. We don't have time for this actually, but it's a fun fact that the Nix packages repository, the official repository, is way, way bigger than any other package manager repository. This is some small text here, but this big red arrow points to the unstable version of Nix packages official repository. All of the dots below are basically different versions of Nix packages repository. And this circle, red circle right here, points to a homebrew repository. So, and this is this graph actually I didn't say. This graph shows number of packages basically. So the higher you are, and on the more on the right, the more packages. So the difference is massive. And that's exactly how we deployed Kubernetes, because NixOS uses those concepts of Nix, creates the declare environment, but for the whole operating system. And that's why we could do this. We could enable K3s just by typing this line, and basically K3s developers packaged all of those things from documentation into a Nix service, or Nix community maybe did that, I don't know, but package it into Nix service, and so we can just use it like that. So how do we actually deploy something? We had 2 minutes, goddamn. So how do we deploy something? So we're gonna use a library called kubenix, which lets us manage Kubernetes also with Nix. We're gonna use Nix for everything. So let me just show you. Let me show you action. Let me show you some action. We're gonna enter the root flake.nix. This is a bigger one, but in the inputs, like I said, you import some stuff. We import the kubenix, and this is a package called kubenix, and this is basically most of this stuff is some template code that you can copy on GitHub. But what this lets us to do is, if we just run a magical command, you don't have to know what this command does. This is actually kubectl for anyone that knows Kubernetes. This shows us what is running on our server, and let's add something by just typing it into our project flake.nix. We're gonna add something to our server, and we don't have any LSP in here. I hope I get that correctly. But I guess we're just gonna deploy some basic Docker image, spec, right? Spec. This stuff usually lives in the internet, and you copy it from there. Containers, main. That's a name, I think. Okay, we're gonna go with one of my very advanced application, which is just a text server. We're not gonna use it. We're just gonna see that I can run now Nix run, which, oh shit, my bad, I didn't say that. And right now kubenix, the Nix run basically runs the main executable of this package that kubenix exposes to us. And this basically, kubenix evaluates the Nix code, generates all of the stuff that we didn't have to write. We just wrote this one line, and when I accept this, it will sync the Kubernetes cluster that we deployed on the server with the code that we wrote in Nix. So right after this finishes, if we check out what is running on our server, it will be 3 things, which are pods, but 3 things. And this is exactly what we declared here. If we remove it, it will be pruned and removed from the server. So that's exactly how we deployed the blog that you saw. We built the blog app, which is a ban frontend with Nix. We then made from this package, can you see my cursor? We made a Docker image from it, and we actually referenced this Docker image. Actually, we didn't do that, but we did, yes. Reference this blog image name and tag in the code that describes our Kubernetes cluster. So when we just make some changes into our source code of our blog website and do git push and have some smart GitHub action that just builds this infrastructure code, it will build all of the things by a chain effect. I hope that was not too much information in in one go. So this is a summary. So we basically, what we did. Okay. We use Nix for everything. We deployed Kubernetes with Nix. We built our application with Nix. We packaged it in the Docker image, connected to Kubernetes with kubnix, and deployed the app with kubnix by declaring the stuff in Nix in kubnix. So you can do basically everything in Nix, and you don't really care much about Kubernetes, I guess, if you don't want to. So that was it. Like we said earlier, we have made a blog for this. And on this website, there's actually a link to repositories. You can browse to the source code as well. And that's it. Thank you.
I love that. I absolutely love that. Do you know why Nix configs are so scary and convoluted? Because Nix was created in 2003 as someone's master thesis, basically. It was a guy from a Dutch university. That's crazy.
And actually, I am reading this paper right now, this original paper.
Lovely. All right. Do we have any questions? We have questions right there. Okay, I'm running.
Thanks for presentation. I never heard about the Nix before, so thank you. I will deep dive in that topic. But I have a short question. Why is that better than Coolify?
Well, I'm not. Coolify is like an open source Vercel or something, right? So I'm not exactly sure what Coolify offers, but I guess you have some UI and you can deploy there, something like that.
Yeah, it's like Firebase, Supabase, essentially.
Well, I think the main thing that is better than Coolify is the Kubernetes itself, because you can do, like, if you, for example, can you deploy ClickHouse to Coolify? Okay, so you can deploy anything you can build open source. Okay. So any like cutting edge technology, unstable anything, right? Not just what's supported. Okay, okay, so that's great. I actually don't really know what to say. Do you have an idea? Oh, and what's the? I mean, not just Nix, but I guess Kubernetes by itself could be much better because there are many extensions to Kubernetes and many operators that so you can do very cool stuff with Kubernetes. Do we have Coolify in Nix? Let's see. Oh, we don't. And how do you deploy Coolify? Oh yeah. Oh, okay. I actually saw that. Okay, so I'm actually not sure what Coolify does, but
All right, folks, I'm sorry, but you've had a very long 4-minute part of your talk, but so we're just stretching over the thing because we have Rafał Pocztarski coming up next. And first, we're going to have a round of applause for those fantastic people. It was amazing. Thank you. And please, welcome once again. You start clapping for Rafał Pocztarski. Thanks. And yep. Yep.
Hello. Okay. Hello. So, if anyone would like to, get some links on the slides or maybe some code examples, then it is available on my website pocztarski.com/stg, which is for switching to Go. And my name is Rafał Pocztarski. I am a software developer at Paramount. In my free time, I'm playing at Code Wars because you always have to get some good, work-life balance. And when all you do all day is write TypeScript, then you want to just go home and write in some other languages. So I noticed that when I write my solutions on Code Wars, they tend to look something like this. So this is probably like the reaction that I cannot write a code like this at work. So I just free myself from the restrictions of readability, and they tend to look like this. Then you start to write examples like this. of course, it's always nice to compare yourself to other examples, that other solutions that like have like 5 screenfuls of text, and this solves the same thing. But then you start looking like some faces in your code, and you think that you are going a little bit crazy when you write a code like this that actually looks maybe impossible, but actually it works. You can see those examples on CodeWars on my collection if you want to take a look. But of course, you would have to write your own solution to see other solutions. But I noticed one thing, that when I started to do some Go solutions on CodeWars, I just tend to not go so crazy as I do when I write TypeScript or JavaScript. So even though those they say the same things, I'm like doing it some crazy ways in TypeScript. Sometimes even some solutions like this one in TypeScript is much more efficient, but like not really efficient in a way that how much time you would have to spend to explain it to someone, because it's like, or even understanding myself when I was digging up those examples. Those are pretty old, and only when I looked at the Go example, I just understood, okay, I know what is going on right now. It's like, can be simplified, could not use the map for the memory. But then I noticed that like when I write Go, I'm not going so crazy as when I write TypeScript or JavaScript. So, I, like few years ago, I started thinking that I should just maybe switch to writing Go professionally, because on my daily basis, I write mostly TypeScript on the backend with Node.js. But there is like one problem, that I am not exactly like known from writing Go. So when anyone like tries to, when I try to like apply for some Go job, then someone checks me out, and like everything is about me is about JavaScript. By the way, if someone would need some consulting with jQuery, then I have a silver badge on Stack Overflow. I might do some freelancing if anyone is interested, because this is like my best days of doing front-end work before I switch exclusively to backend. So maybe someone would like to know it. And then when I was like, for a few years, thinking about switching from TypeScript to Go, I noticed a post announced by Ryan Kavanaugh, but the developer lead for the TypeScript team at Microsoft, and also the talks by Anders Heilsberg, which is incidentally he wrote Turbo Pascal, which was my like first serious programming environment when I was a kid. So, and they actually announced that the TypeScript itself is going to move to be implemented in Go. So I was a little bit disappointed that like not when I was planning to switch from TypeScript to Go, it actually turned out that TypeScript itself is switching faster than me. So, but it is an interesting subject. They announced it on the discussion at GitHub that you can go here. There is the issue. Ryan announced it first, then Anders Heilsberg explained the decision. And actually, if you like to read some flame wars that are going on in decisions like this, like maybe you are a fan of reading like the old discussions between like Linus Torvalds and Andrew Tannenbaum about like which is better, like the microkernels or monolithic kernels in operating systems, then you can be not disappointed when you will be reading the comments under those threads. I actually wanted to get some screenshots, but it was very hard for me to choose something, because there is like mostly the sentiment is that like, first of all, why not Rust? This was like #1 question. The second question was, why not C#? Even some people like said that they are like ditching C# programming altogether, because this is like an insult for them that someone who is like known for leading the C# development chose Go instead of C#. But it's interesting that like I didn't hear anything like this when TypeScript compiler was written in JavaScript or TypeScript, that people were complaining. But when they switched to Go, then everyone is disappointed that they didn't switch to their own favorite language. But actually what was very interesting is that they got like instant 10x speed up of the compiler just by doing some automatic translations, because they didn't like, this is not like a full rewrite. They call it a port because they wrote some tools to automatically translate the code written in TypeScript to code written in Go. And for me, that is the most interesting thing, that it was even possible to do. So So for simpler projects that are written already in TypeScript, it's not such a big effort to go. For some reasons, people were asking why not Rust, for example, because there is no like garbage collector there. So it could be had to be completely redesigned, the memory management. But as you can see, this is like those files have like 12,000 lines of code, and they are very similar in TypeScript and Go for the new compiler. So this is very interesting. But what is also very interesting is how people feel very strongly about the choice of the programming language. So a lot of people are disappointed about like why not Rust, why not F#, why not C#, why not Haskell, why not the most of the discussions is why not something else than Go. But it was of course very good because they could explain why actually Go was very good fit for that. Like for example, they didn't use a lot of classes in TypeScript, but more functional programming that Go is good for. They did a lot of relying on garbage collection for automatic memory management. So also going to a language that doesn't have garbage collection would be much harder than going to Go. And also they get for free a lot of good optimization, like the 10x speedup is just mainly because they can utilize more cores automatically, not rely on web workers or something like this, or other processes as they had to do with TypeScript. So this is something to be watching on. Now there is a preview available that we can use to get the Go version of the TypeScript compiler, but this soon will be the official way to compile TypeScript. So probably everyone will be using it. It is not that surprising that the Go language is used because Docker is written in Go, Kubernetes is written in Go, Terraform, a lot of software that we use. So why not the compiler? But traditionally people are using a lot of, Rust is very highly used for things like this. There is this fast compiler for TypeScript already in Rust, so people are already using. I already am over my time, so fortunately I guess this was my last slide, but I don't see the slides anymore. So I don't know why, but yeah, it's going crazy like my CodeWars example, I guess. So I guess that I had some, I don't know, links on the last slide, which might be possible to show, but no, this is the speed up, and yes, thanks a lot. This was not a lot of time, but I don't know if the pilot is working. Okay, so yeah, so let's be like allies on CodeWars if anyone is interested. We already also has the WarsawJS clan on CodeWars, so if anyone sets your clan to WarsawJS, then we will be automatically following each other's solutions. So thanks a lot.
Perfect. Oh, that's crazy. My first language is also Turbo Pascal. And I'm also doing some tasks, some challenges on CodeWars, which is with the meta programming JavaScript. There's a lot of fun challenges where you have to write programs with two sort of characters on one line, which is a lot of fun. Anyway, yeah, we no longer have a time for questions, so we have two more lightning talks, and the second one is Hubert Sosinski coming up. And please, give him a round of applause once again. Lovely. So yeah.
Working.
Yep.
Should we cancel the cloud? Short answer, yes.
Thank you. And now it's over.
Thank you. Long answer is loading. Yep.
We have a whole office full of software engineers who cannot figure out how to share slides. It's fine. It always happens.
We were taught that at university. Let's stay with the yes answer.
Still yes. We have so many anti-cloud talks today.
Yeah, guys from the next presentation taught a lot of the same thing I will tell, so maybe we can show the video from them.
Perfect.
Okay.
Off you go. 5 minutes.
Okay, so I'm Hubert. I'm currently working as a senior React developer, but I have plenty of experience on backend and architecture. So today I present you my answer to the answer to the question which often pop up to the small teams or developers. Should we use the cloud for our project? And cloud providers promised us a lot of things like simplicity and complexity, but did they deliver? Or did we trade it for rising costs? First of all, what I'm about to say is 100% my personal opinion, so I'm not here to actually cancel your subscriptions. But if you are running a global streaming platform, cloud is probably a good fit for you. But let's talk about small projects, indie developers, and side hustles. Do we need that overhead or no? So let's see about what they promise and versus the reality. We were told that simplicity, pay as you go, infinite scale, but often we get jungle of services, surprise builds, and hours spent on configurations, only to find out that all we can do is all we want is a simple page to the app. So here's a story from my experience. I had a successful running React application that oh, thank you. That ran on a small $10 per month virtual private server, and I've been asked to add a notification to send notification to Microsoft Teams. So I had to create notifications proxy for that. So the documentation said that I can use Azure for that. Simple Azure service to do some notification proxy. So I did. And boom! Now I had $40 per month architecture, just because our simple Azure service costed us 3 times more the server. So I decided to move our proxy to our server, which was already paid, and until now it works for $10 a month. Here is much more impressive example. Poland Alex was the site that ran on Polish presidential elections, and they served 43 million requests in 4 hours, and all that on the server that costed $20 a year. No AWS, no surprise costs. Could you imagine what would be the bill for that on AWS? Remember that the creator of this site didn't anticipate the popularity of this site, so he couldn't prepare for that. It was a side hustle. So what you can get for as little as $5 to $10 full control and easy access via SSH, observability with easy logging and debugging, predictable billings, no hidden costs, and most importantly, no panic attack when the invoice arrives at your email. And last but not least, no vendor lock-in, because when you use Azure, you probably have to use Azure for the sake of the product. So you can maintain a peace of mind, but by not using so much hassle. Stop deploying your to-do applications like we are Netflix. We don't need that. Start simple server. You learn some basic Bash, learn some basic Linux, and maybe that's all what you ever needed. Thank you for the attention, but Side note, you can have multiple sites on one server. Thank you.
That was lovely and very much on time. Thank you for that. And because of this, you might want to ask some questions. No? Any questions? Because, yeah, everyone knows everything about the self-hosting thing. I love self-hosting. And as you said, you might consider learning just a little bit of Linux. And if you like it, maybe you'll switch to Linux for desktop. So anyone who uses Linux for desktop? Hell yeah! That's the, yeah, I don't know. I love it. I've been using Linux for desktop for over 12 years, and I enjoy it a lot. Yeah, well, I don't know why I mentioned that, but yeah, I guess it's when you start using Linux for desktop, it's just like it's your contract. You have to. It's the same as with I use Vim as well. Like people who use Vim have to say this. Sorry, it was completely unrelated to it, but yeah. Anyway, thank you so much once again, and yep, right, lovely. So we have one more lightning talk, unexpected, and Pavel is here. Yes, Pavel Kovalevsky. Kovalevsky, that's correct. Yes, is coming to talk about. I actually don't know what about. It was a surprising lightning talk. So
actually, this one will be completely different, not technical. So I hope that maybe it will be some rest after at the end of the day.
Yep.
So I guess we are ready to start.
Yeah, once you can
Okay, anyway, I will
entertain
just
the
show you
audience.
some things at the end. So I will just share my screen. Or
Yes, just share the screen and or
okay.
the application you want to.
Sure. So I will just share it in a while. So guys, we are all here tonight for JavaScript, which is supposed to solve problems. But sometimes when we are working on some solutions to certain problems, I realize that we create other problems and also some side effects. For me, one of these was the fact that I spent most of my days in front of the computer coding in JavaScript, TypeScript, whatever, you name it. And as a result, also, unfortunately, I slouch quite a lot and I have huge problem with bad posture. And even though I know about it, I always slouch. And I was thinking, like, how can I solve it? Luckily, I have some friends who are physiotherapists, and I asked them about, those things like Pioncheck, if you are aware of this. Like, there are a lot of, supportive and reminding devices. However, the thing is that most of them, like, despite the fact they are not comfortable and so on, they are also weakening your muscles most of the time, not even making them stronger. That's how I actually came up with building my own solution to my own problem. That is super simple app. And yeah, I've been building for almost a year so far. Even I managed to gather a small team around it. And I was quite shy about publishing it, but why not? Maybe some of you will find it useful, so who knows. So with that, I would like to show, and I will just share my screen. I think we can see it right now, probably, yes. So this is our app, Straighty. You can just check it out. We are just at the straighty.app. So what it does, basically just reminds you about your posture. By the way, just for the record, we are not startup. We don't have any money. We are not funded. We don't have any VC fund. Nothing. Just like a simple hobby project that we've been building for almost a year right now. It's completely free. So if you want to check it, thanks to JavaScript right now, we have also a very basic version on the online, so you can just check it how it works. But for the full version, let's say, we have only the Mac OS version right now on the Mac Store, Apple Store. I just published it a few days ago. As you can see, we are still today third, so I think quite nice, but just in Poland, so yeah. So if you'd like to check it out, I can just open the app and show you how it works, and basically that will be it. By the way, that's interesting because I'm sharing my camera and it will use the camera actually. And as you can see also, it's quite light, just 6 megabytes, so not that much. Yep, so let me just turn on the app. And that's all. So for example, I stand in front of the computer. That's my desired posture, just so shoulders and neck. Unfortunately, we don't have the possibility to check your legs, which are also important, but that's still good enough. And for example, like that, I don't want to stand like that. That's all basically, You can also mirror yourself something like a debug where you can just check it, what's going on here. I can also run the app in the background like that. And for example, imagine just I'm just doing something like that. I don't know, for example, some of my Swift code here for the app. So, and we can just stand like that for a couple of seconds. I will get the notification probably because I'm sharing right now. It's not visible, but there will be, yeah, here's the notifications you can see. Yeah, so that's all basically. Nothing else than that. Yeah, if you like it, if you find it interesting, please just check it out. We would love to, but this is the battery saver mode. We also have this link here, so you can just, we would really appreciate your feedback, because what's the point of building if there are no users? And maybe if you even like it or don't like it, just let us know. That's all. Thank you so much.
That is incredible. I really struggle with bad posture a lot, and maybe I'll use it. Yeah, I was like, maybe I was the first thing when I saw it, I was like, oh, maybe we can integrate something like a shock collar. When it's like when you have bad posture, it just zaps you, and you're like, oh, yeah. All right. Any questions? No. Everyone? Yep.
Yeah. Thank you.
All right. Are we gonna have our slides back? We can try. Okay, we will try to get our slides back. But in the meantime, I would like to thank every single person here for coming and enjoying all the talks. And now we obviously know that Cloud's bad, Warsaw is bad. Just kidding. We love Warsaw. But yeah, thank you so much for coming. I'm just stalling until we get the slides so I can show you some of the exciting next talks that are coming for the next meetup, which is going to be on, oh, that's not the correct slide, but it's fine. Oh, right, the survey. So most importantly, in order for us to deliver the best possible experience, I want all of you to take out your phones and scan this QR code, which just gonna take you through a small survey, and so you can give us the feedback on the talks you've heard today and general sort of anything that you felt, and any strong good or bad opinions you have about the day that just happened, please let us know, right? Okay, I see people scanning, still scanning out. I'm gonna keep it here just for a little longer. Perfect. All right, and Meetup 129, that's gonna be on August 13th. We're gonna have Marcin Borkowski about streaming, chunking, streaming, and review. There's a lot of, this is a really fun topic, to be honest. I've just recently been sort of reading about transformed streams in Node.js. It's a really cool topic. I'm looking forward to it. We're gonna have Piotr Migdał and talking about Rust with AI and VASM, which is fun. Oscar Korczak about talking about prompt compression, and a secret speaker, I guess, to be announced. So stay tuned and look on our website, check it out from time to time. So, yep. Yeah, so another QR code. This is for, so you can get the earliest bird ticket you can get, the lowest possible price. You can scan this, and it's going to be probably something dirt cheap. I don't even know. But yeah, all of us can afford it. We're IT professionals, right? The rich people living in Poland. Sorry. Yeah, and if you're especially rich, you can afford a yearly ticket, which I usually advertise that I still in fact am paying for tickets to get here because I got the yearly pass, and every single time I forget to buy a ticket, and now I no longer have to. I guess I don't have to because I'm emceeing the meetup, but still, yeah, I still got because I want to support the community, right? So yeah, if you want it, scan the QR code and you'll have it. And yeah.
Let's have a photo together.
Yes, and now we'll have a photo together. So all the people, please now come here and feel yourself as a speaker, and we'll take a big picture together.